Welcome back. Today we're going to be looking at linear and absolute value inequalities, the two types of things other than equal signs, pretty much, for this entire class. So let's get started with our creed. Remember, you say the creed, you do well in the class. You don't say the creed, most times you don't do well in the class. That's just kind of how it goes. So here we go. Today's a new day. I can read and remember well. I can develop my viewpoint and apply it correctly. I have eyes to see, ears to hear, and a mind to understand. It might not be easy, but it is worth it. Let's get started. Linear inequalities and absolute value inequalities. I made this big chart right here, this table with a bunch of columns that you can read through. I'm not going to read through it just so I don't bore you. But as we look through it, we're going to look at interval notation, set notation, open, closed, infinite, infinite being open always, and what those brackets look like, what the line graphs look like, and that kind of thing. And I think it's going to make a whole lot of sense once we get started. I think you'll be happy with this section because it really is a little bit of review, and it's not too wild. Well, you'll see right away. So we're looking at this thing, and it says express each interval in set builder notation and graph notation, which means it's already been put into what's called interval notation. Okay, so when we're going to convert it to set builder, we're going to just draw these squiggly brackets like we put all our answers in, the sets of numbers. We're going to write x, and we're going to say, okay, what is x in between? X is in between -1 and 4, right? And then we're going to ask ourselves, does it include -1? Well, because of this soft bracket or this curved bracket or this parentheses, it does not include, right? Whoops. It does not include. And because of this hard bracket or this squared off bracket or this bracket, it does include on the other side, which means we can put a line underneath it and we're done. That's set builder. So then, that's sets. So then we draw our number line and you just draw the numbers you need. So I'm going to start at -1, 0, 1, 2, 3, 4. Boom, that's all the numbers we need. And we say, all right, I'm going to draw my curved bracket or my parentheses at -1. My bracket at 4, just like that, and I'm just going to shade in between, and you're literally done. And that's it. That's not so crazy, huh? So the only hiccup or the only off thing is sometimes you have this infinity, right? And if you have an infinity, you do the exact same thing. 1, 2, 3, 4. It doesn't matter where you start. I'm going to go -5, -4, -3, just so we can see that. We've got a open bracket at -4, right? A curved bracket. And then we just shade towards infinity, which is the way it goes. And we never end it, right? We never really end this one because it doesn't end. So if I were to write that in sets, I'd say x is, and we'd start at -4, and do we include it? We look at that bracket, it's open, so we do not include it. And we just close it up and say it's got to be bigger than x. We don't have to, this is just a little side note, we do not have to write is less than infinity because guess what? Every number is less than infinity, right? Every potential real number that x could be is less than infinity. So it's not necessary to write that. And that's it. That's converting interval notation to graph and set builder notation. All right? Here we go. Next, sometimes these things can intersect. And here's the way I like to teach or remember this is an intersection, right? The symbol for it looks like an N. So I just like to think of intersection. And then you can remember it. It starts with an N, right? It's like an intersection. And if you think about a Venn diagram, if we do a blue circle and a red circle, then the intersection of that Venn diagram is usually made purple, right, in the middle. That purple section is what the intersection is. It's where those two things. So as we move forward, I'll do these in different colors, and you can see where they intersect. And then union, it starts with a U, right? And so U, yin. And if we did the same Venn diagram with blue and red, right? Red and blue, the union is not where they intersect. That's the intersection. And it's not the outside, right? It's not the not or the negation. It's literally everything. So if it's going to be, let's not make it purple. Let's make it green. I don't know why, just because. It's everything. It's everything that's included in one set, the other set, or both sets, right? Okay, so let's see what happens. We're going to do this just like the other one. It's literally just like doing 2 of the problems we did before. So we need to go from 1 to 8, which is a lot of numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11's fine. So I'll start at 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to, let's break them into blue. Let's make this one blue. And red. Let's make this one red. All right? So we're going to start on the 1. Open bracket at 4. And then I'm going to shade it in, right? Okay? And I'm doing my graph first because it look, the example even says use graphs to find each set. So we're going to do the graph first because it makes it way easier to see the set builder notation being created. So 2 to 8, let's see. Hard bracket or a closed bracket, including bracket. Closed bracket including, right? And then I am going to just slowly graph that. And we should start to see where the intersection is, right? Now, before I move forward, I'm going to copy this over so that we can use the same numbers for our union. Look at that. Boop. That's going to be great for later. And here we go. So we're going to look at this and we're going to say, where do these things intersect? And it's kind of I think it's pretty easy to see a lot of it, right? If I'm going to do this in purple, it's pretty easy to see this section, right? I think the only tricky parts are 2 and 4, right? Well, the cool thing is we just get to use those symbols that are right there because does the blue set include 2? Well, absolutely, because it's still inside of it, right? And does the red set include 2? Yes, because it's got a closed bracket. So we can start with 2. And then how far do we go? Well, does the purple set include 4? So we ask ourselves, does the red set include 4? Well, absolutely, because it's in the middle, right? Check. Does the blue set include 4? No, because the blue set has an open bracket at 4, right? It stops at 3.999999999 forever. So it doesn't include 4, which means that the intersection does not include 4. So we're going to stop at 4 and open it up, which is cool because we just get to use the same symbol that's in the middle right there when we're looking at our set. Okay? And then we can build our set builder off of that intersected interval, right? So I'm going to go x is in between 2 and 4 and look at my closed or open for which one gets underlined. Cool? Well, let's hop over to union. Union's way easier. Remember we said it could be blue, red, or both? So look at this. Blue, red. So now to do the union, we look at this and we say, okay, it includes blue, it includes red, and it includes everything in the middle, right? We don't even have to worry about that because it could include blue alone, red alone, or both. So it's including all that stuff. So if we're going to do this purple interval, it starts at 1 and goes to 8, right? If we were going to write that in set builder notation, I'd write x is in between 1 and 8. And it only includes 8, but not 1. All right? There's a few properties that they bring up to us. And the properties work pretty much exactly like equal sign properties. There's only one difference, which is this bottom one. And you can look through the notes and read through this and see what I wrote on the notes. The only difference, and I do this every time I see it, anytime I see a divide by a negative, right here. If you divide by a negative, every time I highlight it real big and I put a star and I put flip inequality. Every single time I do that. I'll be like, flip sign, flip sign. Oh, so yeah, I'll usually say flip sign. Every time, as soon as I do it, I put a big highlight there because I'm just like, I don't want to forget to flip the sign. So let's see. We'll do one flip, one not flip. So let me look at which one's not. Oh, they're all flips. No, let's see. We'll do the first one. This is a flip. So we need to get x by itself, right? So we treat it exactly like an equal sign. How we do what you do to one side, you do to the other, right? So we subtract 3. You're left with negative 2x less than or equal to 8. Divide by negative 2. Divide by negative 2. Whoa! I said the words divide by negative, right? So I always, this is what I do. You don't have to do it this way, but this is just how I do it. I always highlight it, hop over here and say flip sign. As soon as in my mind says the words divide by a negative or multiply by a negative, my brain knows to flip the sign. So then on my next step, I can just flip the sign and know that I did it. And you're done. That's your inequality. It does say graph it. I'm going to go ahead and do set builder, x, bar. And then we're saying negative 4, x is less than or equal to. And we don't have to include that infinity. So if I was going to graph that, just do 3 things. There's negative 4, there's negative 5, there's negative 3. Is x going bigger or smaller? It's going bigger, right? And does it include it? It does include it. So it just looked like that. Not too crazy. All right. Sweet. Sometimes you have rationals. That's okay. Sometimes you have to distribute first. That's okay. You're still solving it just the same exact way. Looking through all those. Okay, we're going to look at compound and absolute value, and then we'll be done. I know it's a short unit. That's awesome. So compound just says sometimes you have two inequalities, right? And basically what it comes down to is if you can get those two inequalities to have a matching term, whether it be x by itself or this 2x plus 1 right here, then you can combine the inequalities. Likewise, if you got the same thing in the middle, you could create two separate inequalities. It works both ways, right? You could break it apart into two inequalities, which we'll see later with the absolute value, or you could combine them if you have the same thing on one side. And to do this, to solve these, we treat them just like normal, but now what you're doing to one side, you do to both sides, all three sides. So if I was going to subtract 1 like I would to get x by itself, now I have to subtract 1 from all sides, right? So now I've got negative 4 is less than 2x is less than or equal to 2. If I was going to divide by 2, now I have to divide by 2 on all sides. Did I divide by a negative? I did not, so I don't highlight and I don't put the sign. I'm left with, I don't care if I got a negative. Like right there, I got a negative. I don't care about that. What I care about is if I divided by or multiplied by a negative. All right, and there's your answer. If we were going to set that up, we'd set it up in an x bar, negative 2. Sorry, it's kind of messy. If I was going to put that in a set, it'd be bracket x is included in the set from negative 2 to 1, including 1. All right? And if I was going to graph that, I'd probably just draw negative 2, negative 1, 0, 1, 2 maybe. I go negative 2, negative 1, 0, 1, 2. And I'd go, okay, it does not include negative 2. It does include 1. And it does include everything in between. Dunsies. Cool? All right, last thing is this absolute value of inequalities, which is the coolest thing. This is the coolest thing because sometimes when we're doing this absolute value of inequalities, I'll just give you a little sneak peek. This is when our graphs look the coolest. This is when our graphs could look like this, normal style, or sometimes they could look like this and go outwards, right? And that's going to be super fun. So let's look at this. It's a whole lot like the absolute value of equalities, which we did in literally the last video before this. But all we're going to do is if you can get the absolute value by itself, what you have to do first, you need to get the absolute, not the thing inside, just the absolute value by itself. What that's saying is we can't have a 2 right here multiplied, right? We can't have a minus 4 on the outside. We need to get rid of everything. And as soon as we do, what we can do is we can add the exact same sign facing the same direction and flip the sign. So then I'm left with added the sign, got rid of the absolute value, did that. And now what I need to do in my brain is ask myself, does this make sense? Is there some number that is greater than negative 3 and less than 3? Well, yeah, I can think of lots of them. Zeros and ones, negative 2, 2, all those. Okay, we're good to go. We do that check because sometimes we don't. And if it doesn't make sense, if the greater number is on the flip sides, then what we're going to do is break it into two equations. Okay, well, here we go. We're going to solve this just normal style. Plus 4, plus 4, plus 4. It's kind of fun that you get to do it on 3 sides instead of 2 sides now. 1 is less than x is less than 7. You are done. I'll let you set builder that. I'll let you graph that. I lied. I want to graph it because it's so fun. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Boom. Open. Open. Right? They're both open? Yep. Shade the middle. I just like graphing them. I think it's fun. But I'll let you do the set builder. All right, let's find one where it does the wrong flippy thing, and you'll see. Probably these last two. All right, so what do we say? We got the absolute value by itself. We did all the work to get there. And then what we're going to do is we're going to draw the same sign and flip the sign. Well, hold up. This is where it gets weird. Can you think of a number, question mark, that is bigger than 7 and less than negative 7? No, there's not one, right? That number doesn't exist. So what we're going to do then, because we got into this weird case, is we're going to break it into two equations. We're going to say that 5 minus 2x, it better be greater than 7 and, no, or, I said and. Well, it does include it. No. It is the union of these two sets. It's all of the things including these sets, so it would be an and. X could be any of those, and x could be 5 minus 2x. You'll see when we graph it why. All right, so break it down. get x by itself, and you probably end up with minus 5, 2 less than negative 2. Ooh, I see something cool coming up. Divide by negative 2. Hold up, before I even do it, I'm going to do this highlighter. I'm going to do this orange thing. It's always orange for some reason. Flip, sign. I'm literally going to do it before I even do the thing. I just flip the sign just because I knew it was coming. Now I got to finish the problem. So now we've got x, negative 1, and we've got x is less than negative 1 as half of our answer. Now let's solve the other one. I bet we do another flip sign. Minus 5, minus 5. Looks like we're going to do another one. Negative 2x is less than negative 12. We're dividing by, oh, I'm not even finishing it. I'm highlighting because I don't want to forget. I do not want to forget to flip sign. All right, let's keep going. When you divide by a negative, it turns into a positive, right? That's the whole point of dividing by the same thing, so it turns into 1. So we've got x is less than 6 as our other solution. So when I go to graph this, I need the negative 1, so I'm going to go negative 2, 1, 2, or 0, 1, 2, 3, 4, 5, 6. There's my 6. There's my 0. There's my 2. There's my 4. Okay, and now we got to think slowly. X is less than negative 1. Let's just do that separately. Here's negative 1, open bracket. Wait, was it open or closed? Yep, open. Now, which way is less than? Left or right? It's to the left. Okay, I can do that. Now let me do my other one. X is... Oh no! You were probably screaming in your chairs at home, right? Look at this. What did I literally highlighted it? See, I told you. This is why I highlight it and write that every time. Because look at this. This is crazy. I'm baffled by this. I highlighted it. I wrote flip the sign. And then what did I forget to do? And if I can forget to do it, then you know you're taking a test. You're nervous. You're stressed out. It's easy to forget, right? Make sure you do everything you can to help yourself not forget stuff like that. Flip the sign. Maybe I wouldn't have forgot if I wrote it out instead of just abbreviated it. Flip sign. That might have helped. Good golly. All right, let me graph this thing. X is bigger than 6 with an open bracket. It's going to look like that, right? All right. So hopefully that helps. Hopefully that's like kind of easier. It's like a little break from all the algebra and the arithmetic and the polynomials. And it's just kind of a nice breather to kind of graph, do a little bit of graphing, do a little bit of solving, and do a little bit of converting notations and stuff. Remember interval notation, set notation, graphing. Remember the special rules about flipping the sign if you divide or multiply by a negative. And remember the special rules to how to get rid of an absolute value inequality, that you have to have it by itself before you can apply that special rule. All right, thanks for watching. I'll see you soon. Study hard, prepare good. I'll talk to you in class.